it's important to know how far two vectors are from each other. Say we have these two vectors A and B, with A being n-dimensional and B n-dimensional. To find the distance between A and B, it suffices to subtract the two vectors and find the magnitude of A minus B. So the magnitude of A minus B is simply the magnitude of this vector which is formed. And with this we have A1 minus B1 squared plus A2 minus B2 squared up to AN minus BN squared, and all of that square root. So this is how we found the distance between two vectors. Now, the magnitude of A squared equals A dot A. This means A minus B magnitude squared is equals A minus B dot A minus B. We've replaced A by A minus B. So we have A to A minus B and A to A minus B. A minus B dot A minus B, recall, is actually A minus B transpose A minus B. Now, A minus B dot A minus B, using the properties given to us previously, we have A dot A, which is this, minus A dot B minus B dot A minus B dot minus B, which is plus B dot B. This is equals the magnitude of A squared, because A dot A is actually the magnitude of A squared. B dot B is the magnitude of B squared. Negative A dot B minus B dot A is minus 2A dot B. Remember, B dot A is A dot B. So we have negative A dot B minus A dot B, which is negative 2A dot B. Let's also look at this geometrically. We have the vector B and the vector A. To obtain negative B, we simply move in opposite direction to B, but maintaining its magnitude. So that's how we do to get this negative B. Then to have A plus negative B, we take the tail of negative B and put on the head of A, as we saw previously. With this we have negative B, which moves to the head of A, and then A plus negative B becomes this vector. Once we have this, we can form some sort of triangle with an angle between A and negative B being alpha. So we form this triangle. Making use of the cosine rule, we have magnitude of C squared equals magnitude of A squared plus magnitude of B squared minus 2 times the magnitude of A times the magnitude of B, the cosine of the angle between A and B. Now, what's C? C can be considered to be A minus B, and that's what we have here. A remains A, B remains B, and we have this expression. Back from this former expression we had, which was A minus B magnitude squared equals magnitude of A squared plus magnitude of B squared minus 2A dot B, we can compare with this other expression. And notice that comparing these two makes you see clearly that A dot B equals magnitude of A times magnitude of B times the cos of the angle between A and B. And this leads us to this formula, which is very popular, wherein A dot B equals magnitude of A times magnitude of B, the cosine of the angle between A and B. We've now seen 3 different ways of getting the distance between two vectors. Let's take an exercise. Deduce the following assertions. The angle between two vectors is 90 degrees. Then A dot B equals 0. So show that if the angle between two vectors A and B is 90 degrees, then A dot B is equal to 0. Show also that if two vectors are moving in the same direction, then A dot B is equals the magnitude of A times the magnitude of B. For the first one, we have A dot B equals magnitude of A times magnitude of B times the cos of the angle between A and B. And given that the angle between A and B is 90 degrees, the cosine of 90 degrees is 0. Hence, A dot B equals 0. For the second, if they're in the same direction, then the angle between them is 0. We have the cosine of 0, which is equals 1.